So, Andrew, can you tell us a little bit about yourself?
Sure. I'm a lecturer at the University of Aberdeen in the School of Engineering. I've got 20 years' experience of applying and developing artificial intelligence techniques, so that's kind of what I want to talk about today.
Okay, and so Sarah, can you tell us a little bit of why this is of interest to the OGTC?
Yep, so in the Wells team, we've been looking a lot at automation recently, and as part of that, looking at artificial intelligence, big data, machine learning. And one of the things we've actually come across as part of that is the fact that we maybe bought into a few myths and a bit of the popularity around AI and big data and machine learning, that maybe our perceptions of what it is, what it does, how it can be used weren't quite what the reality was. And after speaking to Andrew, we've kind of got this presentation that he's put together for us. It kind of myth busts some of those preconceptions that we have about it, so we can really learn as an industry what we can do with these technologies.
Okay, so that's us. So, Andrew, with no further ado, your 20 minutes start now.
Okay, so this is a title phrase. This talk's going to be quite generic. I guess some of the more technical stuff might come out towards the end. I'm not sure what your level of understanding of AI is. So I just thought to start with some examples of AI that's been in the media. We've all seen a lot of these stories. This is an example of self-driving cars. So this is saying it's going to enter mass production. So this is an application, obviously, of AI, which industry says. We have another one, which is there's a recent claim of a chatbot which beats GPs in a medical exam. That was on BBC a few days ago. We've also got Google's Robot Caller. So this is where you have your personal device. You get Google to phone up a restaurant and make a booking for you. So it will phone up, make the booking, and let you know that it's been made. Okay. So again, this is using different forms of AI. So these are all coming under the AI bracket. Here's another one. So Adobe saying it can identify manipulated images. This is important for fake news. You know, recently that's an increasingly important thing. So here's another application of AI. This one's an interesting one. So this is on Google's own site, and it's talking about an application of AI to learn and teach AI. So we've got AI on top of AI. We might come back to this later. This was an article in Forbes, which talks about how Amazon, then we know that they've got Alexa and other things, so that's obviously using AI. But the article's talking about how Amazon have totally changed their business and made it, all parts of their business have an AI focus. So all of the business developments, every product development, everything's focusing on AI, and they think it's going to give them massive benefits to their company, without necessarily telling us exactly what AI they're using. And then here's a couple of projects. So this is one that I'm involved in. This is directly oil and gas. Here we have a company, WFS, that creates subsea sensors, basically. And the AI here is going to fit on the sensor so that it can make decisions subsea because it's on its own. Okay, so that's where the AI is going to fit. So that's kind of a bit closer to home. And then there's another project which is just about to start, which is funded by the OGTC. It's another one that I'm involved in again. And this one is working with Halliburton and their landmark software. And this is looking at developing AI to help the decision-making during the design process when you use a landmark software. So this would be AI embedded inside a software. And we could go on. There's many, many more examples, okay? But that was just to give an oversight of some of the things. So the talk is going to try and give us an idea of what we mean by AI, because it's used for lots of different technologies and applications. What about machine learning? What about deep learning, if you've heard those terms, because they've come up quite a lot. And also talking about what is big data, and is my data big enough for it to be classified as big data, and should I care? So before we kind of delve into AI, I thought it was useful for us to understand the process that we go through when we're building an AI kind of model. And this is what this picture over here is showing us. On the outside, there's this big circle with arrows on. This is basically implying that we have an iterative process. So this is something that we have to go round and round and round to get our AI model working well. And we start off with a business understanding. So what's the business problem we're trying to solve? Then we move on to what data might hold the information I need. Then we have maybe some things we need to do to the data. Then we get to the modeling part. So that's the box that has the AI inside it. And then we come back, we evaluate, is it good enough? Is it not? If it's not, we go back to the beginning and we start the process again. And this is run by a human. A human kind of operates all these processes. And this is called the CRISP-DM. So this is Cross-Industry Standard process for data mining. So this is something that can be applied to lots of different industries. So it's a generic process that can be applied to the examples that we've seen before. And this is the process that companies go through to come up with an AI solution. The point is there's only really one box in here, which is AI. So there's quite a lot of other things we need to do in order to implement an AI solution. So let's then talk about some definitions. So if we have different types of data, we have numerical data or we have textual data, we have to treat those differently. And that means we'll have different technical AI kind of technologies, some of which really shouldn't even be called AI to handle them. So we need different techniques for numerical data and textual data. It can be very difficult to combine text and numbers together inside of AI, and we might need to treat them separately. And in terms of oil and gas, or looking at applying AI in an area, we should numerical problems are often much easier to get started with. There can be textual problems that are easy to solve as well, but they're often just a bit harder to come up with a solution. But numerical data also has its own problems in terms of combining data and transforming data and so on. So we'll come back to here again because I thought it was useful to look back at these problems and see what type of AI is being applied in each of the solutions. So this is our automated car again. So this has got sensors on it. It's going to have proximity sensors to things that are near it. It's going to have cameras taking pictures, which will try and automatically work out whether it's a car or a bus. But basically, this is numbers. So all the sensors are giving it numbers information. So the AI behind that is going to be numerical based. The chatbot is different, and clearly this is looking at text. So this is going to be completely different form of AI. The chatbot also needs to have a memory. It's going to ask questions. It's going to remember those answers. That will lead it to understand what the response is, lead on to the next question, until eventually it can make the diagnosis for that particular patient. Robot caller. Okay, so this one is slightly different. You can see it's linked to that one because it's got text. But this one's also having to use a form of AI to understand spoken words, convert that to text, and then it will use the same technology as this one. And then it's also going to have an AI to then convert what it thinks is the answer into a voice to then talk to the other person. And some of the things that they do to make it less robotic is they modulate the tone and things like this. And this is also AI that can help us do these sort of things. So what you can see with this one is that we've got AI for different parts of the process. And this one is similar to that one in that we've got images. So we're going to have numerical data, numerical techniques to find AI to find when they've been manipulated. The AI on top of AI I'll leave just now. And then the Forbes one as well is all the different types of AI, so we don't need to talk about this one. For this one, the oil and gas, so this again is sensor data, so we're using numerical type approaches to work out what the sensors are recording, when they are different, and then highlighting. So the sensor machinery itself will then make a decision based on a sensor values to return maybe, oh, there's something happening, has something gone wrong. And then for the Halliburton Landmark project, we have a lot of AI integrated into the software. This one's going to be using numerical data and categorical data. For example, different types of pipe, different lengths of pipe, these sorts of things. So it's going to be a combination of numerical and categorical data, and that will make decisions based on historical data to give predictions of what should be put into the design going forward. So lots of different examples and lots of different types of AI have to be used for each of these examples. So although the media might talk about a single kind of AI process, actually there's lots and lots and lots of different methods underneath this, and many of them aren't even AI. But the media calls them kind of AI. So if we're going to build an AI process, the first issue is to define our business problem. So what's the problem we're trying to solve? And where and what type of data holds the information? So where are we going to go to try and solve this particular problem? And is the data numeric? Is it textual? Is it categorical? Is it image? Is it combinations of these, or is it something else entirely? And then there's another issue we need to consider before we move on to implementing AI, which is, are there problems in the data? Do we have missing values? Are there inconsistencies in the data? This could be data's entered in wrong, or it could be very noisy values. Now, we can use AI to help with that step, but we should go through that step before we think about implementing any type of model. And only once our data set is cleaned should we then look to apply a suitable algorithm in the modeling stage, which may or may not be AI. So what AI should I use? And what even do I mean by AI? So this top line, read it in one go. So we've got optimization versus traditional AI techniques versus statistical approaches versus machine learning versus deep learning versus evolutionary learning. These are all kind of approaches which in the media will probably come under the label of AI. But which one should I use? Well, it depends. Optimization techniques are kind of glossed over and no one really talks about them, but actually are very, very powerful. They're not very sexy. They're not, it's nothing to do with AI. They're just old techniques. But they can be very, very extremely powerful for particular types of problems. Statistical approaches, similarly, are not new, so they're not very sexy either, but they're also very powerful. But they can be hard to implement because we need to have a very good understanding of our data to be able to implement a statistical type approach. And they're not as flexible, so we need to be careful about using those. Evolutionary learning, for example, genetic algorithms, which you may have heard of, also very powerful, and they allow us to basically explore the input space for a particular problem. So for example, let's say we had a series of wells, and we wanted to work out how to connect them. There's lots of different ways we could connect them, lots of different types of pipes, lots of different types of ways to get the oil out, and so on. Genetic algorithms would allow us to search that space and to find out solutions that would be the cheapest or the quickest to implement or optimal for flow production. So then that brings us on to machine learning, deep learning, and AI. So deep learning actually is AI. It's a form of AI. And in fact, I've kind of been doing deep learning for years without realizing it's deep learning because it's kind of a marketing term. And it's linked to the fact that computers are much more powerful than they used to be in the past. That allows us to do neural networks, which are AI, much, much bigger than we were before. And also we can get access to cloud computing, which allows us to basically have hundreds of thousands of AI models all running at the same time, and we can work out which one's the best. That's kind of the approach that Google and Amazon take, partly because they've got that resource. Not all of us have that resource, obviously. But this is part of the reason why the big companies are getting these big results, because they can just throw resource at it. So I didn't really answer the question, right? The last slide was, what AI should I use? Well, the answer is, it depends on the problem. So there isn't a single approach. So magic bullet, say use this AI approach and it will give you your answer. It very much depends on what the problem is. And sometimes AI is definitely not always the ideal solution. And when I'm building solutions, when I'm looking at a particular problem and trying to go through the process of finding a solution, my endpoint is not predetermined to be AI. I'll use AI during the process. And often AI can help me find a solution, but it might not be the actual, the deployment of the model might be something else. AI can help me find what's important, and then I can use another approach to then to give the final solution. And I try not to use AI as the final solution, partly because most AIs are black boxes. But there are certain problems where AI is very much the appropriate technique, and deep learning or machine learning allow some problems to be solved very easily and without really much expertise. So we can kind of just throw certain problems at deep learning and it will give us an answer. But they are black boxes, so they will not tell us why they've come to a decision. So for some problems, that isn't good enough. We need to know why. We need to understand what is it that is leading to a particular decision being made. That could be business critical. We don't want a black box making a decision without understanding why it's making a decision. Where does big data fit in? So big data, the formal definition of it is really related to huge amounts of data, and we definitely have that in the oil and gas sector. So the seismic data, for example, it definitely meets the requirements of huge amounts of data. There's another definition of it, which is that there's many ways to transform and analyze the same set of data. So you could imagine sensor values from a number of sensors. There's a time series data, and then we want to try and analyze that to try and identify if a fault's going to occur. There's a myriad of ways in which we could analyze that data. So that also could come under the category of big data. But you shouldn't care about this formal definition. It really doesn't matter. Big data for your company might just be a few thousand rows of data that you just can't analyze. And that means it's big data for you. So this is really, big data is really just, again, a marketing term. And big data also will change depending on the computational power we have, which is increasing all the time. So back to this picture again. As we've already pointed out, only one box in this figure is done by a computer. Done by the AI, which is the modeling box. The arrows are indicating the steps undertaken by a human. So a human is the one who is deciding what the business problem is. They are then deciding what data I need to look at, The human then decides, okay, I'm going to transform the data and look at different things. The human then decides which AI model to use to try and solve that particular problem. They then evaluate whether that response is good enough. And if for the first time they do, it's likely not to be, so they come back to the beginning and they say, okay, do I need more data or different data, or do I need to transform it differently? Or maybe I need a different AI approach, because there's so many to choose from. So that process goes round and round until they come to a solution that is acceptable. So we need an expert who can do all these things. And that's the issue with using AI, is that we need a human to do many of these tasks. So that's the problem of implementing the kind of approaches that Google and Amazon have been able to implement and get these headline results from. So one of the things that I've been involved in at the university is automating that part of the process. So this is a spin-out company called Blueflow, which has the IP for this type of approach. So this is recent results, so we're very excited actually by how we've got to. So this is our normal picture over here, where we have our iterative process. We have to go through it. And the reason that this process is like this is because the AI is a black box, and it doesn't tell us what's important. So what I've been focusing on in my research is how can I go about working out what is important? And so the recent results have shown that we can work this out, given a numerical data set. So this is not for text at the moment, just for a numerical data set. But we can identify what features are important for any given data set. So we can say, okay, for this particular problem, you need this data, and this is the relationship you're looking for. And if you look at this problem, it's this data, and which might be different, and a slightly different relationship. And that means we cut out a lot of the iterative process, because it comes through and it says, well, the best you can get in your evaluation is this, and that's either good enough or it's not. And if it's not good enough, then we need to think back on this part of the process up here. The results, when we compare them against other methods of AI and machine learning methods, shows that we are better than basically all other methods. And this is what's really exciting. And this is world-class research done right here in Aberdeen. So the most important thing about that is that we explain why and how decisions are made. Okay, so here we go. I'm going to try and get this little demo going. Yes, it worked. So this is just an animation kind of describing what you do when you're building a model. So this is a guy who is building an AI model. He's got a particular tool. The tool is good for soft rock, but not good for hard rock. And so he breaks his tool. And that's kind of what could happen in reality when you're doing data mining. So he goes away, and he's like, oh, that didn't work. What should I do? I need a bigger axe. So he comes back with his bigger axe, and then he's going to start trying to go through the data to find these nuggets of information that are relationships he's trying to find. And this is the real process, and it takes him a long time. And he works all night because you've said to him, I need this by tomorrow. And then he still can't find an answer, so he gets really tired, and he goes, right, I'm off. So then you're like, oh, I didn't get the result, so let's throw more resources at it. Let's be Amazon and Google. So then they throw all their resources at it, and they throw lots of data miners who are doing their data mining. They've got right axes and everything, and they're going away. And then this guy at the end, he absolutely uncovers a solution. So he's like, woohoo, I found the answer. I'm off. And then he doesn't necessarily find all the answers. And then these guys continue, and then this guy gets flattened. And then this guy is going through the data, and he's going, right, I'm going to go through it all. I'm going to be really thorough. I'm going to find all the results. He finds all the results. The problem is he didn't look at all the ways to analyze the data. So that kind of summarizes the real data mining process today. And if you're going to implement AI methods, that's the process you'll go through. And it's really down to how good the person is to whether you find the solutions. And then this dusty bin guy is meant to be my algorithm, which then sucks up all the data and then spits out the answers and what data can be used and tells you why and stuff along the way. So, little dusty bin. Okay, so that's the end of my talk, so I'm just ahead of time. So
Perfect.
I guess
top of the class. So not only are you ahead of time and your video played, everything's working.
I know, first time.
I'll grab that for you for now. Okay, so we're now going to go into the Q&A. So as ever, if I can ask you just to raise your hand if you've got a question, and then let Lauren with the mic come to find you, and that's just to make sure we can pick up your question on the recording. Mm-hmm. So what questions have we got for Andrew? Gentleman here.
You talked about machine learning and deep learning.
Yeah.
And I'm a drilling engineer, so I certainly don't do the latter, but I'm not really familiar with either of them. So could you say a bit more about what those things actually are?
I can describe it technically, I guess. But so deep learning is basically a neural network, which is a form of AI, artificial intelligence. Machine learning is a process which some people could say could fall under statistics, but it basically allows you to separate data into classes in a mathematical way. So machine learning does that, and it finds a way to separate data. Whereas AI goes beyond that in a different way. But they're lumped together because machine learning often can be used to help AI. But basically what it's about is if you've got lots of parameters, so it's numerical data normally, you've got lots of parameters, you want to work out how can I diagnose a particular problem. So I've got faulty and not faulty. So I want to know with all my data, how can I identify faulty, not faulty? So machine learning can be used with all the parameters that you've got, and it will try and divide the space so you've got faulty and not faulty on either side. It can do that if the data it's given is good enough. So this is where the human comes in. The human goes, right, okay, so what features shall I give this machine learning algorithm to try and separate? So you give it some features, and it will either be able to separate or it won't. And if it won't, then machine learning can't do anything. And it's also big black boxy, so you can't really look and see what it's done. You just need to then go back to the original data set and say, okay, those features didn't work. Let's try some other features. So then you try other stuff. Eventually you get to a point where you think it's good enough. So you might get 80%, separation, and you say, well, that's good enough, so let's stop. And actually, some of the tests that we did when we were testing my algorithm against published research, there was one particular example which was, so it's not oil and gas, but EEG data. So this is where you have sensors on your head, and they were trying to work out when you used your right hand, or your left hand. So one hand over the other. So that's all it was. It wasn't particularly a health thing. It was just trying to work out which hand was being used. So the published research, and it's open data as well for you to kind of get to have a go yourself. They were able to get 92% accuracy using machine learning methods. And there's 3 bands, there's alpha, beta, and gamma kind of wave bands in these EEG. So that was just one of the bands. The other 2 bands, they got like 70%. But when we used our techniques, we got 100% in all categories. And the reason we did was because we know what's important. So we looked at the data, the EEG data, and we said, okay, so this data is irrelevant, we can get rid of it. But this data is important. So then that's when we get 100%. And interestingly, if you take the data we say it's important, we improve their 92% to a higher value. So the machine learning also did better based on what we were saying. So it's just one of the techniques. I mean, the thing about the things we're talking about there, all the applications of AI, machine learning will have been used in some of those examples. It's kind of just under the umbrella of AI now. So it's one of the techniques that you use.
Thank you. Next question.
Hi, a great presentation. Simon from Wood. For people who want to learn a bit more about this, what was your first book on the subject? What's your go-to thing for people who want to learn more?
Yeah, I think the books are awful, actually. Actually, there's a lot of free courses you can do. So Coursera, for example, online, there's data mining type courses, and they're free. You just sign up. I mean, they're good starting points, and they cover 3 months worth of kind of material. So they're good places to start. So, and that's free. So there's quite a few like that online. Coursera, yeah. So it's course with RA on the end.
Yeah, hello, my name is Fabian. Thank you for the presentation. You said you make some tools to automate some of the iterative processes. Mm-hmm. So what exactly do you do there? So you say you need to make a model selection and a feature selection. Is that what you're talking about, or do you also apply this to the data aggregation problem and the cleaning?
Yeah, so it's the whole thing. So the data. So you start off with imagine the picture. We've got a data problem, and then business problem. We define that, and we say, okay, the data's here. This is where my data is. I could transform the data in different ways. So let's do that transformation. That gives me an enormous data set that I can try and that I think the information that I need to do the predictions is in. And then you give that to my process, and it will tell you what features you can use and what features are irrelevant you can get rid of. And it will give you the best diagnosis as well. Hard sell. But it's true. And that's why we're so excited, because it's not black box. Whereas the approaches we described, the normal AI, this is actually why Uber, for example, had this problem with the car crashing into the lady and killing her was because the algorithm they developed didn't explain properly what they were doing. So they developed an algorithm which, under certain training conditions, gave the right answer, but when something else happened, it acted in a way that wasn't expected. But it would have been expected if they had understood what precisely it was looking at. So that's the difference with the current approaches and what I'm trying to develop.
Thank you. Next question, Anna. Getting your step count up, Lauren.
Thank you. Thank you for the presentation. My question is, so Blueflow has the purpose of automating the data analysis. Is it also looking to understand how AI is making predictions or decisions or interpreting the data that it's exposed to?
No, this purpose isn't about understanding AI. Its purpose is understanding the data, and it will tell you. So AI, traditional AI will take a data set and it will do, say, a function approximation, so big black boxy thing, and it will work out, you give me these inputs, I give you this output. But for you to understand what's inside that black box is really difficult. So what Blueflow does is it takes the data and it says, okay, so this is the data you need for this, and this is the relationship you're looking for. So it could be, high value here, low value, whatever relationship is. It tells you what the actual relationship is, and it tells you what features to look at to diagnose your particular problems. After that step, you could choose to implement AI on the features we say are important, because you now know what's important and what the AI will be looking at, because you still can't see inside what it's doing. If the relationship's simple enough, you could use a statistical approach or something else, or even if-then-else rules, if the relationship is simple enough. So the issue here is to understand what's important, and then the model thing will depend on how complicated that relationship is.
Thank you.
Sure.
Thank you, Andrew. Next question, just at the back here.
Hi, thank you, Andrew. Lovely presentation. Can you explain to me why you focused on numerical data and not necessarily text data and visual data? Is there an obvious reason why you wouldn't?
One, it's different technologies and different problems. So in part of the research I'm doing at university, we are looking at text as well. So again, we're looking at different approaches to try and handle some of these problems. And it comes back to the same thing. A lot of the textual approaches have the same issue, which is you can't always know what the black boxes are doing. So we're trying to develop methods. But because it's text, it's slightly different. And it's technical stuff, I guess, underlying it, why. But the textual problem is still there, and it has the same issues. So we're in terms of like Blueflow, say, and the automated, we're slightly behind. So the numerical was done first, and then the text we're working on.
Thank you. Next question. Sarah. That's her own mic.
What do you think is the biggest barrier in the oil and gas industry from kind of the uptake of AI and machine learning?
That's a good question. So one of the issues is data, because the business problems, I think, are quite well defined. So where do we get the data from? And we know that some of the data is in different places, right? All over the place. So one of the issues is getting hold of the data. And one of the problems, I think, is that it's a bit of a catch-22 situation, in that the benefits of the approach can only be proven when you've done the approach, right? So proving that it will really give a benefit to the industry, I think, might take some leadership from the industry. And if you look at, it's part of the reason I put up the Amazon kind of Forbes story, because Amazon have taken the decision, they can see they understand what AI can give them, and they are choosing to put it in all aspects of their business to try and improve their business processes, product development, whatever it is. They're saying, what can AI do in these areas to help us? So they're choosing to do it. So, the oil and gas industry should look at, I think, like things like Amazon, to see that if they take a leap, they could have big benefits.
This lady here, and we'll get you next.
Do you see then growing leadership within oil and gas industry in terms of this approach?
Do I what, sorry?
Do you see increase and drive from the leadership in oil and gas with regards to AI and data?
Everyone's here, right? So this is a good indication, I think, of the appetite for new methods. So I hope it's there. Yeah.
What would you say would be an area for oil and gas to start in? If you say, well, we don't have the right data, or we might have pockets of data, would you say there's a specific area which we can pilot or something like that?
Yeah, I think this is an interesting one because when I've had conversations with the oil and gas industry, this is often what happens. They say, you tell me where I should use it. No, you need to define what the problems are, and then we can tell you what are the low-hanging fruit, if you like. So, what areas do you have problems with? What areas could be improved upon? Or what areas do you think are wasteful? And then we can look at what's behind all that and say, okay, well, these ones, that's quite straightforward for us to kind of find some solutions for. These ones are a bit harder. So we could try these ones first. So I think it takes discussions, conversations. People like myself, there's other people at Aberdeen, there's RGU, there's other universities in Scotland as well, all expertise in this area. It's just about getting those conversations going.
And here.
Hi, Steve Aiken. So would, with what you've got, it be possible to present an oil and gas user with, here's all the data you've got, let's say you had access to it, what do you want to improve? I'll go find throughout all the rest of the data what I could use to decide how to improve it.
Yeah.
Okay, let's do that.
Cool.
Yeah, thanks.
Done.
New project right there. More questions? Graham, is that you poised?
No, I was just going to say I'll give you a starting point right now.
Okay.
Okay, any more questions for Andrew? We've got some time, so another couple. No?
Sorry, it's kind of to build on my last question. You mentioned, we do have this issue with data quality and the use of all the data being maybe on paper form, textual form, cluttered. Can we use AI and machine learning to declutter the data to actually get it into a more usable form?
Yeah, there's a few things we can do. So some of the data has been OCR'd already. So if you've got access to that, converted from. So some of the reports were just paper. They've been scanned, and then the OCR converts that to text. So that obviously means that we can start putting it into some of these AI processes. The issue is that the OCR process itself could introduce errors. It might read it wrong. Turn the 5 into an E or whatever, things like this. So AI can definitely help with cleaning that up. It can identify things that are wrong and help you correct them. It can also, so let's say we have reports from different areas in the North Sea over a period of time, and those reports have also changed. So the amount of information that's been captured has also changed over time. AI can be used to fill in some of these gaps. So you could use AI to make an educated guess as to what the missing data actually is. And you can give a confidence level to that missing data. So you could say, okay, well, we can fill in some of the gaps. We can give a prediction as to what that value would have been, and I can give a confidence level as to my prediction. So that AI can do that part of it as well. And that allows us then to build more data, more confidence in the data. And then that comes to your question then, which is like, well, what things can we use with the data that we've now got that can help us moving forward?
Thank you. And there's a question here.
Yeah, the research you did for Blueflow to identify the particular application, did you do it specifically on oil and gas, or was it cross-industry, or what was the test bit?
So with that, we've done financial services data. So I've worked with hedge funds. We've done health data. So I took that EEG stuff, and there's oil and gas kind of condition monitoring type data in there as well. A whole host of different problems. Yeah.
Okay, was there a question over here? This gentleman here. Just wait for the mic. It's on its way.
Thanks. Ian Middleton. You mentioned RGU there, some of the work they're doing. I assume you'd be familiar with Professor Simon Burnett, the Professor of Knowledge Management there. Where do you see the overlap? I mean, do you actually do any collaborative work there, and how do they fit together?
I don't, but I'd be more than willing to. I know John McIntyre, RGU, So, there's some good people there, and it's just, like I was saying, with the get together with industry and then work together on the problems.
Happily put you in touch.
Okay. Any more questions? Anna, another question from Anna.
You're testing my step, So, following up on Sarah's question, artificial intelligence can be used to analyze big data and to extract relevant information. At the same time, big data is used to teach artificial intelligence and to provide it with useful input. Would you say that they're connected in a way that they depend on each other and independently so their functioning depends on the connection between the two areas?
I think, yeah, so it's an interesting question. So what you're describing is some of the limitations with some AI techniques that they require, like, so for example, deep learning requires lots of data for it to go through its process. And because it's a black box, because it's not really explaining what it's looking for, it therefore needs more data. So it's a bit like a statistical kind of thing. So normally in AI type problems, you want as much data as you can possibly get, which is the same for statistical approach as well, really, to improve your confidence levels. So you can think of it in those terms. But I think it's also exposing some of the weaknesses of some AI approaches. So they're very, very good at certain problems. And big data, if you look at images, that's kind of big data because they're so big. And deep learning is very, very good at classifying the images, but it's poor at explaining how it's made that decision. And so that's kind of the drawback. So it's highlighting that weakness, I think.
Thank you.
Thanks, Andrew. Any last questions? We've got time for another couple. Gentleman here.
Following up on your last answer, you said AI is bad at explaining why it did things, and it's essentially a black box. Why is that?
It's how it works. So the way in which they work mathematically, they take in, so I think neural networks, which is the main form of AI, takes in inputs, which is our numerical data, let's say. It goes through a process which is supposed to be similar to our brains. We have these neurons in our brains, which then, as I'm talking, it's happening to all of us, so that our brains, the neurons fire and send signals down axons, which then, in a big, massive parallel kind of process in our heads, allows us to make sense of things. So neural networks are a kind of approximation of that process. And when we put in our input data on one side, these neurons are all joined up, and we have this kind of network of neurons like our brain. And at the far end of it, we have an output, which is the thing we're trying to diagnose. The way in which we train these neural networks is through a mathematical process called backpropagation, which kind of means that it's quite hard to disentangle through all these connections what exactly it's doing. And particularly with deep learning, when we have massive number of neurons, so there can be thousands and thousands and lots of layers, so it can be very, very big. And it's very, very difficult then to understand it. So that's kind of why. So it's the way in which they actually work. It means it's difficult to understand what they're learning.
Okay, thank you. Okay, so that pretty much winds it up for us today. Sarah, have you got anything you want to say before we close up?
Yeah, it's just a big thank you on behalf of the OGTC to Andy for presenting today, and I'm sure you've all got a good insight now into what we're talking about when we say AI and deep learning and machine learning. And I'd just like, as a final word, to kind of encourage people to take a think about where AI and machine learning could help our businesses in the oil and gas industry. And if there is anything, particularly in the wells domain, that springs to mind, please come and have a chat with me at the end. So thank you very much.
Okay. Thank you.